Bismillahirrahmanirrahim. Assalamu alaikum. Hope you are fine and taking your online classes regularly. In this course, you have advantage of taking lectures from a variety of teachers, and each and every teacher have some different way of communication, and from this you will learn you will improve your communication skills, and your understanding level will be higher as compared to the students who are teaching a course from only one teacher. This is a lecture amines. This topic will comprised of total 4 lectures. In the first lecture, we shall talk about introduction of amines, their nomenclature, their classification, and we shall also study there some common and industrial methods of preparation. Actually, there are two modes of preparation of any type of organic or inorganic compound. One of them is the method that is being used in laboratories, and the other one is that the methods which are used on commercial level. So we should be very much clear about the preparation methods of any compounds. So initially, we shall talk about their chemical composition and their mode of bonding between various types of methods. Amines are compounds which have 3 different types of atoms. These atoms are carbon, hydrogen, and nitrogen. Amines are usually termed as derivatives of ammonia, as we know that there are 3 hydrogen atoms attached to a nitrogen atom in ammonia. So replacement of these 3 hydrogen atoms by different types of alkyl, cycloalkyl, or allyl groups give them a different type of amines. As far as their occurrence is concerned, many of the amines are naturally occurring compounds and very active physiologically. Numerous drugs that are used for the treatment of mental illness, heavy fever, heart problems, and other physical disorder are composed of compounds belonging to the class of amines. As far as a classification of amine is concerned, amines are usually classified into 3 classes: primary, secondary, and tertiary amines. This classification is based on how many hydrocarbon groups are bonded to ammonia nitrogen atom. As we discussed in our previous slides, that amines are derivatives of ammonia. So depending upon substitution of hydrogen atom with different alkyl group, give them a different category. So first of all, we shall talk about the first class of amines, that is primary amines. An amine in which the nitrogen atom is bonded to one hydrocarbon group and 2 hydrogen atoms is known as primary amines. The generalized formula for primary amine is RNH2, and if we take a particular example, means R stands for any type of alkyl group, and if this alkyl group is methyl, then this molecule will be named as methylamine. The functional group present in primary amine is NH2 group and known as amino group. An amino group is NH2 functional group, and at the bottom of this slide you can see the open structure of primary amines. You can see that there are uh, 2 hydrogen atoms attached to nitrogen and one bond is with alkyl groups. In this slide, we shall talk about the rest of the 2 classes of amines, that is secondary and tertiary amines. A secondary amine is an amine in which nitrogen atom is bonded to two hydrocarbon groups and one hydrogen atom. The generalized formula for a secondary amine is R2NH. And for a particular example, means both of the alkyl groups are methyl, then this molecule will be named as uh, dimethylamine, and you can see the open structure in which nitrogen is linked with two R groups. The one of R group is simple R group, and the other R group has a sign of prime, and the third bond of nitrogen is with hydrogen. So this R prime means it is not necessary that both of the alkyl groups are of similar nature. They could be similar or they could be of different nature. It means at one side there may be a methyl group and the other alkyl group may be alkyl propyl butyl. So it means both of the alkyl groups is not necessary of same uh, nature. They can be different. Now we come towards the third class of amines, that is tertiary amine, an amine in which nitrogen atom is bonded to three hydrocarbon groups and no hydrogen atom. The generalized formula of a tertiary amine is R3N, and we can see in open structure all of the bonds of nitrogen are to different or similar alkyl groups. The example coded here has all of the R groups are methyl groups, so this molecule will be named as trimethylamine, and these three alkyl groups could be of different nature, and we will see in our coming slides while we shall talk about their nomenclature and their synthetic methods. We shall encounter various types of primary, secondary, and tertiary amines. This slide is about the nomenclature of amines. You guys are very much familiar with the nomenclature of organic compounds. There are two common practices for the nomenclature of organic compounds. First one is common names, that they have don't any sequence or rules. The common names are usually based upon the name of scientist or the process, or means there is some historical factor related to the name. And the other one is IUPAC system that has some basic rules and regulations. The common names of amines are derived by using a suffix amine preceded by the name or name of alkyl group attached to nitrogen atom in alphabetically order. The prefix di or tri are used for identical alkyl groups. The name is written as one word. Uh, Salts have two words name. Usually organic compounds are molecules, so all of the molecules have one word name. For this one, I can quote a very simple example like sodium chloride. Sodium chloride has two words name. There will be always a space between sodium and chloride because it is a salt. But organic compounds like benzene, acetone, all of the organic compounds are molecules. That's why they contain one word name. First molecule is a primary amine. It has methyl group. That's why its name will be written as methylamine. Second one is a secondary amine, and we can see nitrogen is linked to two alkyl groups and one hydrogen atom. Both of these alkyl groups are same. That's why its name will be written as dimethylamine. And at the third example, nitrogen is linked to three alkyl groups, and all these three alkyl groups are propyl. Propyl has two types. One propyl is known as isopropyl group. That's why it is necessary to mention in the name as normal propyl. That's why this name is written as tri-N-propylamine. Now we come towards the second row of molecules In this, we can see at the start is CH3CH2. It is an ethyl group, and the right side there is a CH3, that is methyl group. And we have studied in their rules that the name of alkyl group is written as alphabetically. That's why ethyl methylamine will be written as the name of this compound. Now we shall come towards the second molecule of second row. In this, the nitrogen is linked to all of three different alkyl groups. At the top right, there is a methyl group, and bottom right, there is an ethyl group, and at the left side, there is a cyclopropyl group. As I told you earlier that for the open chain there are two types of propyl group. One of them is normal propyl, second one may be isopropyl, and the third possibility of propyl group is cyclopropyl. So alphabetically, first of all comes C, that's why the name will start with cyclopropyl. Then we know there is an E alphabet, that's why cyclopropyl, ethyl, and methylamine. This name will have no any space, any hyphen, or any comma because this is a single molecule and it will carry only one word name. Now the last line, there are some complicated examples, but no need to be worried. Just focus on basic rules that we have discussed in the earlier part of this slide. Again, we shall focus on the nitrogen. Nitrogen is linked to different alkyl group. At the top right, there is ethyl group. At the bottom right, there is a methyl group, and left hand side, there is a cyclohexyl group. So whenever there is a cyclo group, it will carry usually first because alphabet C is star is comes in the very start of our ABC. So cyclohexamethyl, then there will be ethyl methylamine. The last example is much complicated and difficult. In this, again, we shall focus on the nitrogen. Nitrogen has three bonds. One bond of nitrogen is with hydrogen, and two bonds of nitrogen are with the benzene rings. So it means this molecule also belongs to secondary amines. 4,4 dimethyl diphenylamine. From the carbon atom of benzene ring connected to nitrogen, we shall count the number this benzene ring, and the methyl group comes at 1, 2, 3, and 4 position. Both of these benzene rings have two methyl groups at their respective 4 positions. That's why we have mentioned here 4 4 prime. The mentioning of prime at the second 4 is to demonstrate that 1 4 belongs to one benzene ring and fourth prime belongs to the other benzene ring. If we write the name of this molecule as 4 4, then it will be reflecting that both of the methyl groups are connected to the fourth position of one benzene ring. That's why it is necessary to differentiate that both of the methyl groups are connected to different benzene rings. That's why it is written as 4 4 prime dimethyl diphenylamine. Benzene ring, when it has directly connected carbon of the ring to any other atom, then it is named as phenyl group. The IUPAC system. In the IUPAC system, the ending E of the name of parent hydrocarbon containing NH2 group is replaced by amine. For secondary and tertiary, the longest chain is selected as the parent name as usual, as we know from the nomenclature of alkane, alkene, alkyls, alcohols, phenols, that the longest chain is taken as parent chain. Parent chain. And in case of equal chain length, the parent alkane is one with greater number of substituents. The remaining alkyl groups are named as substituents by using prefix "n" to indicate that they are attached to nitrogen. So here are the names of amines based upon their IUPAC nomenclature. In this first example, there are 1 and 2 carbon atoms. So 2 carbon atom chain is named as ethane, but to mention its functional group amine, its name will be written as ethane amine. So E of ethane has been eliminated, uh, and you know this is a very general uh, thing in English. When two words are connected, usually the last alphabet like E is eliminated. The second example, it has 1, 2, and 3 carbon atoms. So the parent chain is propane, but to include NH2 group, its name will be written as propane amine. Third example is belongs to a secondary amine, and both of actually this means CH3 CH2, 2 CH3 CH2, two ethyl groups are attached to nitrogen. So the parent name of this molecule will be based on one ethyl group, and the other ethyl group will be written as an side chain. So the side chain is directly connected to nitrogen. That's why first of all we shall mention substituent means N-ethyl, and then we shall write its parent name. The total name of this molecule will become N-ethyl ethane amine. Similarly, the third example is almost fourth example resembles to the third example. In this case, nitrogen is connected to three different ethyl groups. One of these alkyl group will become the part of parent name, and the other two ethyl group will become as substituent. In this case, both of the ethyl groups are connected to similar nitrogen atoms. That's why there will be no mark of prime, as in previous slide we have studied that F44 prime. But in this case, both of the ethyl groups are connected to similar nitrogen. That's why here we shall write NN diethyl ethane amine. Now we shall come towards example number 5. In this case, we shall initially calculate the longest chain of carbon atoms containing or including functional group. So we shall start from the side where there are the substituent is attached to nearest carbon. I think so. Its name will be started from left hand side. See 1, 2, 3, 4, and 5 and 6. So it means its numbering is wrong from left hand side. Yes, the numbering will be started from the side where amino group will get lowest position. So if we start numbering from left hand side, the amino group will get position 1, 2, 3, and 4. But if we start numbering from right hand side, then the amino group will attain position number 3, and methyl group will obtain position number 5. So it means the numbering will start from right hand side. So uh, initially we shall write functional group, that is 5. We shall write substituent, that is 5 methyl 3-hexaamine. Now we shall move towards example number 6. In this case, again, the numbering will be started from right hand side, because if we start from right hand side, then the number 1, 2, the amino group will obtain 2, and there are two nitrogen atoms in this chain. The nitrogen that is present in the center of chain, this is a tertiary amine, and the nitrogen that is attached as a substituent is primary amine. So N-ethyl, N-isopropyl. The numbering of this chain is started from 1-methylamine. Yes, uh, the numbering will be started from the second carbon, that is written as CH2, and sandwiched between two nitrogen atoms. This nitrogen, that is tertiary nitrogen, is connected to one ethyl group and one isopropyl group. So it will carry name N-ethyl, N-isopropyl. The carbon that is sandwiched between two nitrogen atom is also connected to one methyl group. So 1-methyl ethane amine. Now we shall move towards next molecule. Its numbering shall be started from the right hand side of this molecule 1, 2. At the second position there is a methyl group and N-propylamine. Uh, Numbering is started from right hand side 1, 2, 3 and 3. So there are total 3 carbon atom as parent name. Then the nitrogen is connected to 1, 2, 3 N-propyl group. So the name shall be written as 2-methyl N-propyl propane amine. This is benzene amine. Its common name is aniline, and it has a fishy smell. This molecule is 4-methoxybenzyamine. And the last one is tertiary amine. In this, nitrogen is connected to two similar groups which are known as ethyl groups, and one of them is cyclo. Cyclo starting from C, but these are two ethyl groups. Their name shall be started at D, and I think so. Uh, this name is wrong. The name shall be cyclohexyl. No, sorry, the name is right because the parent name is based upon longest chain or longest string. That's why the cyclohexaamine is parent name, and these two ethyl group are taken as substituents. That's why its name is NN diethyl cyclohexaamine. In more complicated amines, the NH2 group is considered as a substituent on a hydrocarbon, and its position on the chain is indicated by the lowest possible number, like this one, 5 methyl 3 aminohexane. This is a complicated example, so it's not easy to name this one molecule. That's why amino is taken as a substituent. Similarly, in the second example, there are two functional groups. One of them is carboxylic acid, and the other one is amino group. For competitive functional groups, the reactive functional group is considered as part of parent chain. If we compare the reactivity of carboxylic acid and amino acid, then we have found that carboxylic acid is a reactive class. That's why carboxylic acid will become part of parent chain, and amino group will become a substituent. So this molecule will carry a name as 2-amino propanoic acid. In this case, benzene ring is connected to two functional groups, and we have discussed that carboxylic acid is a reactive class as compared to amino. That's why amino group will become as a substituent. So we can write this position as para, and this position can also be written as 4. So 4 amino benzoic acid, or we can write it para amino benzoic acid. The last class is have two functional group, one is NH2 and the other one is alcoholic functional group. So among alcohols and amines, alcohol is more reactive. That's why alcohol will become the part of parent molecule, and amino group will become as substituent. So the overall name of this molecule will become as 3-amino propanol. Here are some common names of a variety of amines, and I think so you must know the name of these molecules, because in your future classes, if you carry your major subject as an organic chemistry, then you must be familiar with the IUPAC name of these molecules. If one amino group is attached to benzene ring, then this is aniline. If two if aniline is uh, attached to one methyl group at ortho position, then this will be known as orthotoluidine. Similarly, if methyl group is at meta position, then this will be named as metatoluidine. And if we replace methyl group by methoxy group, then the name of the molecule will become anicidine. Anthranilic acid is a very common organic compound that is used in our laboratory for various types of chemical reactions. Similarly, the molecule is also known as diphenylamine, and it is also written as biphenylamine. Bi and di, both of these terms are used to represent two groups. Some of the aromatic amines are named as derivatives of aniline, N-ethyl, N-methyl aniline, because in aniline, as you can see in the first example, that nitrogen is attached to different hydrogen atoms. If these hydrogen atoms are substituted by methyl or alkyl group, then the parent name will be still as aniline, and the substituent will be written as their names like N-ethyl, N-methyl aniline, 2,4,6 uh, tribromoaniline. Uh, and the last example is orthonitroaniline. In the next lecture, we shall talk about uh, in detail about the synthesis of amines, and we shall discuss all the rest of them, all the methods that are used for to prepare amines at laboratory level as well as at industrial level. So here are some questions for you. In the lecture, I have talked about three types of amines, that is primary, secondary, and tertiary. This is another class of quaternary amines. It is usually not included as a as a common class of amines. It is something special class of amines. So that's why I have posed you as an assignment question, and there are two uh, Molecules, you have to write their structural formula. With this, I would like to say thank you so much. Inshallah, we'll see you in the coming lecture that is based upon preparative preparation methods for amines. Assalamu alaikum. Allah Hafiz.